Let's now go to trajectories. Three-dimensional trajectories. Trajectories, thank goodness, are almost never three-dimensional. They're always two-dimensional because the trajectory itself is in a vertical plane. And so we normally, when we throw up an object in a gravitational field, you have the trajectory in a plane. So we're going to have one trajectory. Let this be the x direction. And let this be the y direction. Increasing values of y, increasing values of x. I take an object and I throw it up with an initial velocity v0. And what is the object going to do? You're going to get a parabola under influence of gravity, and it comes down here again. And when we have this kind of a problem, we will decompose it in two one-dimensional motions, one in the x direction and one in the y direction. We already decompose right away the velocity at time t equals 0 into a component which I call v0x, and that of course is v0 times the cosine of alpha, if the angle is alpha, and the velocity in the y direction at time t equals 0, I will call that v0 in the y direction, and that is v0 times the sine of alpha. And now I have to know how the object moves in the x direction as a function of time and how it behaves as a function of time in the y direction. So here come the equations for the x direction. X as a function of time equals x0 plus v0x times t. That's all, there is no acceleration. The velocity in the x direction as a function of time is simply v0x. It never changes. So that's the x direction. Now we take the y direction. Y as a function of time equals y0 plus v0yt plus 1/2 at squared. My g value that I'm going to use is always positive, either 9.8 meters per second square, or sometimes I make it easy to use it 10. But mine is always positive. And since in this case I have chosen this to be the increasing value of y, that's the only reason why I would now have to put in minus 1/2 gt squared. Not, as some of you think, because the acceleration is down. That's not a reason, because I could have called this direction increasing y. Then it would have been plus 1/2 gt squared. So the consequence of my choosing this, the direction in which y increases, therefore the plus 1/2 at squared that you would normally see, I'm going to replace that now by minus 1/2 gt squared. Then the velocity in the y direction as a function of time would be this derivative, that is v0 y minus gt, and the acceleration equals minus g. So these are the three equations that govern the motion in the y direction.